Solving Juan's exponential equation. My former pre-calculus student and a Facebook friend, Juan, wanted a little help with his college algebra and asked me if I could help him solve some equations. I asked him to give me an example problem. This is what he gave me as a picture through Facebook. This is the equation e to the x power minus 18e to the negative x equals 3. I saw the multiple choice answer A below, which is 1.9152, and got a little hopeful that he would be allowed to solve this problem using a calculator, and I asked him about it. Because with the calculator, all you would have to do is enter the equation like this, having solved one side of the equation for 0 by subtracting 3. Then graph the function, and here is the graph of that function, and you may be able to see that the solution according to graphing would be that x equals a little less than 2. But Juan's reply was no, that he couldn't use a graphing calculator for this. So let's get right to it. Here's the equation, e to the x minus 18e to the negative x equals 3. In my first attempt on the problem, I factored out an e to the negative x power from both terms on the left side of the equation and worked it out from there. While I was eventually successful at solving the problem from starting this way, I found that an easier way to do it would be to rewrite 18 e to the negative x power as 18 over e to the x power. That's the rule of negative exponents. And here the equation is rewritten. Next, to clear out the denominator, we can multiply the equation by e to the x power as shown here. Here's the equation with e to the x power distributed to each term in the equation. E to the x times e to the x will equal e to the 2x, and e to the x over e to the x will cancel to equal 1 in that second term. We're left with e to the 2x power minus 18 equals 3 e to the x power. The next thing we can do is solve the right side of the equation for 0 by subtracting 3e to the x power from both sides of the equation. 3e to the x power minus 3e to the x power cancel to equal 0 on the right side of the equation. Bring down what's left, and it's e to the 2x power minus 3e to the x power minus 18 equals 0. It may not be readily apparent, but this expression on the left is a variation of a quadratic expression. This equation can be rewritten in factored form as quantity e to the x power minus 6 times quantity e to the x power plus 3. And setting each of the factors equal to 0, we have e to the x power minus 6 equals 0, and e to the x power plus 3 equals 0. And putting the constant term on the other side of the equal sign, we have e to the x power equals 6, and e to the x power equals negative 3. Since e to the x power has to be greater than 0, e to the x equals negative 3 has no solution. But for e to the x power equals 6, we can rewrite the equation as a logarithmic equation, and it's ln of 6, which is the natural log, or log base e of 6, equals x. And that's our answer. X equals the natural log of 6, which we box in as our correct answer. And just for fun, we can enter the natural log of 6 in the calculator, and we get about 1.792, which had to have been one of the decimalized answer choices in Juan's problem. I like this problem because it combined the knowledge of the rules of exponents, factoring quadratic trinomials, and knowing how to change exponential equations into logarithmic equations as prerequisite skills for being able to solve this problem. This has been Solving Juan's Exponential Equation. Thanks for viewing.